Welcome to 9.4. This is surface area of prisms and cylinders. We're going to start with some definitions. First thing is a prism. It's a polyhedron with two congruent faces called bases that lie in parallel planes. So think of it as a 3D shape where two of the sides are specific shapes and the other sides are rectangles. The lateral faces are parallelograms. So quadrilaterals, typically rectangles, formed by connecting the corresponding vertices of the bases. So it's the rectangles that create the prism connecting the bases. The lateral edges are the segments that connect the two lateral faces. And the surface area is the sum of the area of the faces. Finally, the lateral area is the sum of the lateral faces, the rectangles. Quadrilaterals, the parallelograms. So this is what a prism looks like. The bases are the shapes on both the top and the bottom. They don't always have to be on the top and bottom. They could be turned on the side. But realize it's the non-rectangular shapes. The lateral faces are all of the parallelograms or quadrilaterals that connect the two bases. The lateral edges are the edges that connect the lateral faces. So finding surface area. Well, let's first use a net. So here's a rectangular prism, and we're going to open it up and create multiple rectangles, and we're going to find the area of each rectangle. So the left and right, that's the 2 by 6. The front and back is the 5 by 2, and the top and bottom is the 6 by 5. So we can find the area of each face. 6 times 2 is 12, 5 times 2 is 10, 6 times 5 is 30. Then we're going to add up all of these. There's 2 of each rectangle, so we're going to multiply each of them by 2 and add them up, and we get 104. So that's how you find the area of the surface area of a prism. But that's the long way. There's a formula for it that kind of pulls all of these ideas together, and so we're going to find the area of a right prism. So here's our prism. H is the height of the prism, where our 4 sides are the sides of the base. Okay, so if we unfold it like this, we have 2 bases, and we got one big rectangle created by all the lateral faces. So the idea is the lateral area is the perimeter times the height of the prism. And that creates that whole rectangle, right? A plus B plus C plus D, that's the perimeter times the height. The area of the bases is capital B. There's 2 area of the bases, and then there's the perimeter times the height. So the formula ends up being 2B plus PH. The bases won't always be an easy shape. Regular polygons will enter in, where you get 1/2 times A times P. 1/2 times 2 is 1, so it's just A times P plus P times H. So example here. We have a regular pentagon, so we're going to use the formula AP plus PH. To find the area of the pentagon, we're going to do the triangle. We're going to find the apothem. The radius is 6. Okay, so our side length is 7.05. We got the apothem here. We know that half of 7.05 is 3.525. And then to find the apothem, we use Pythagorean theorem to solve for A. So we get that A is 4.85. So the perimeter, there's 5 sides because it's a pentagon. The side length is 7.05, so we do 5 times 7.05, and we find that the perimeter is 35.25. So we know our capital P, we know our apothem, it's 4.85, and the height of the prism is 9, because it's the distance from pentagon to pentagon, and that's on the picture there. So we know A, we know P, and we know our height. So now we just plug in our formula, 4.85 times 35.25 plus 35.25 times 9. That gives us 488.2125 square feet. Alright, our next definition is a cylinder. It's a solid with a congruent circular bases that lie in the parallel planes. Think of it a prism, but the bases are circles. The height of the cylinder is a perpendicular distance between the bases. A right cylinder is pretty much a cylinder where the circles line up right over each other. So using a net here, we have 2 circles, and when we unfold the cylinder, it becomes a rectangle. Okay. The length of the rectangle is the circumference of the circle, and the height of the rectangle is just the height of the prism. And then we got the area of our base is pi r squared. So lateral area is 2 pi r h because it's the circumference, 2 pi r, times the height of the prism. And then the formula for the basis is pi r squared, and since there's two of them, we're going to do 2 pi r squared plus 2 pi r h. So our examples here, we have 20 compact discs with shrink wrap. Each disc has a height of 1.2 millimeters and radius is 60 millimeters. So what's the minimum amount of shrink wrap needed to cover the stack of 20 discs? So the height is 1.2 times 20, which is 24. The radius is 60. And we do 2 times pi r squared plus 2 times pi r h. So 2 times pi times 60 squared plus 2 times pi times 60 times 24. We get 10,080 pi square millimeters. Let's see a couple examples to make this a little bit simpler. Right? We know this is a prism. It's a triangular prism, so we're going to use the triangle formula for the area of the base. The lateral area is just the perimeter times the height. So the perimeter of the triangle is 5 plus 5 plus 8. The height of the prism is 15 from triangle to triangle, so the lateral area is 270. So if the question asks what's the lateral area, that's how we do it. The area of one base, the area of one triangle, is 1/2 times 8 times 3, 1/2 base times height, which is 12. And the surface area formula is 2b plus ph. So 2 times 12 plus 270, because we know 18 times 15 was 270 from the lateral area. What we get is 294 square centimeters. Now let's look at an example of a cylinder. Here the cylinder is 2 pi r squared plus 2 pi r h. We know the radius on the cylinder is 2 because the diameter is 4. And the height is 12. So to find the lateral area, that's the 2 pi r h. So 2 times pi times 2 times 12 is 150.796. That's our lateral area. The surface area formula is 2 pi times 2 squared plus 2 pi 2 times 12. So that gives us 175.93. So that's it for the prism and cylinder.